Welcome back. Let's practice solving equations containing parentheses. All right, so here's our first example. We want to solve the equation and check the solution. And our equation is 6x plus 2 times the quantity 2x plus 3 equals 16. Okay, so this is clearly an equation that contains some parentheses. We have one set of parentheses right here. And what you want to do when you see a set of parentheses in an equation is try to get rid of them. All right, and the way we do that is by using the distributive property. You want to multiply whatever is on the outside of those parentheses by everything inside those parentheses. All right, so in this case, we want to multiply 2 by both of these terms, 2x and 3. By doing that, we'll get rid of the parentheses and then be able to simplify our equation further and eventually isolate and solve for the variable, which in this case is x. All right, that's our final goal here. We want to solve for x. So let's do that. Let's use the distributive property here. We're going to multiply 2 by 2x and then 2 by 3. So we'll have 6x plus 2 times 2x. You can multiply 2 by the coefficient. 2 times 2 is 4, but don't forget to keep that same variable part of x. And then 2 times 3 is 6, so we have plus 6. Okay, and then all of that is equal to 16. And if you've watched some of my other videos on solving equations, then you may be used to me telling you to draw a divider below the equal sign so that when you go to solve the equation, you can easily visualize the two sides of the equation. I'm actually not going to do that throughout this video. If you have been doing this, I want to try to encourage you to now start ditching that. It's going to be easier later on in algebra if you just get used to solving equations by just rewriting the equation each time you make a simplification to it. By this point, you should be pretty familiar with solving these more basic types of equations, which is essentially what we're left with here, or at least it's what we will have after we simplify by combining like terms. Notice that we have 6x and 4x. Those are two variable terms with the same variable part. So you can combine their coefficients and just have one term. All right, so in this case, I'm just going to box those in. We're going to combine 6x and 4x, which will be 10x because 6 plus 4 is 10. So we have 10x plus 6 equals 16. All right, and so now to solve for x, what we want to do is isolate that variable term, and we can do that by getting rid of this constant term. We can add the opposite of that constant to both sides of the equation. All right, or the way that I like to think about it is that we are subtracting that value from both sides. And so then positive and negative 6 will cancel each other out, just leaving you with 10x is equal to 16 minus 6, which is 10. And so then the final step here is to isolate x or solve for it by dividing both sides by the coefficient of that variable term, which as you can see right here is 10. So if we divide both sides of the equation by 10, these 10s will cancel out because 10 divided by 10 is 1. So we get x is equal to 10 divided by 10, which as I said earlier, is equal to 1. So x equals 1 is a solution that we have found for this equation. But now let's check it. Let's see if it really is the solution to this equation. What we're going to do is plug that value of 1 in for each x in the original equation. So we're going to plug it in here and here. If we do that, we'll have 6 times 1 plus 2 times 2 times 1 plus 3 equals 16. And so simplifying, 6 times 1 is 6. So we have 6 plus 2 times what is inside the parentheses here. 2 times 1 is 2. So you have 2 plus 3, which is 5. So I'll just write down 5, and that's equal to 16. Now 2 times 5 is 10. So we have 6 plus 10 equals 16. And 6 plus 10 is 16. So we get 16 equals 16, which is a true statement. And so that means that the solution we found, x equals 1, is in fact the solution to this equation. Let's take a look at another example. Once again, we want to solve the equation and check the solution. This time our equation is 2y minus 5 is equal to 4 times the quantity 3y plus 1, and then we have minus 2. Okay, so once again, the first thing you want to do in order to solve an equation involving parentheses is get rid of those parentheses. Use a distributive property and multiply whatever is on the outside of those parentheses by what is inside. Okay, so in this case, we want to multiply 4 by 3y and 4 by 1. So let's do that. We'll have 2y minus 5 is equal to 4 times 3y, You can multiply 4 by 3, and that will give you 12, but then don't forget to keep that same variable part of y. So you get 12y, and then 4 times 1 is 4. So we have plus 4, and then don't forget about this minus 2 on the end. So we'll have minus 2. Okay, and so now we have eliminated all the parentheses from our equation. Now we just want to simplify by combining any like terms, and then we should have an equation that we know how to solve. And on this side of the equation, we're fine. 2y minus 5 cannot be simplified, but over here, 4 and negative 2 are like terms. Those are two constants that we can combine. 4 minus 2 is 2. So we could rewrite this as 2y minus 5 is equal to 12y plus 2. And so now we have an equation with a variable term on each side, as well as a constant term on each side. This is a type of equation that we have learned how to solve in the past. The first thing we want to do is combine the variable terms by adding the opposite of one of them to both sides of the equation. In this case, I'm going to add negative 12y to both sides, or in other words, I'm going to subtract 12y from both sides of the equation. So on this side, 12y and negative 12y cancel out, but over here, 2y minus 12y will be negative 10y, because 2 minus 12 is negative 10. But then we still have minus 5, and that will be equal to 2, right? 12y minus 12y is 0, and 0 plus 2 is 2. So now we have one variable term, which now we need to isolate. We want to get it by itself. So we need to get rid of this constant term, which we can do by adding the opposite of it to both sides of the equation. So let's add 5 to both sides. That would be the opposite of negative 5. Negative 5 plus 5 is 0. And so we just get negative 10y is equal to 2 plus 5, which is 7. And so to finish our solution here, I'm going to take our work over here. The equation we have right now is a negative 10y equals 7, and we can solve for y by dividing both sides of the equation by the coefficient of that variable term. So if we divide both sides by negative 10, negative 10 divided by itself is 1. 1 times y is y, so we get y is equal to negative 7/10, right? We can't really simplify that. 7 divided by negative 10 is not a fraction that reduces in any nice way. So this is it. That is the solution that we have found for this equation. It's not really a nice solution, but it is what we have found. And so let's check it. Let's see if it really is the solution to this equation. We want to plug what we found for y back into the original equation for each of the y's. So let's do that here. Checking our work, we'll have 2 times y, which is negative 7/10, minus 5, and that will be equal to 4, times 3y, so we'll have 3 times negative 7/10, plus 1, and then minus 2. Now simplifying, you can multiply 2 into the numerator of this fraction. 2 times negative 7 is negative 14. So we have negative 14 divided by 10 minus 5, and that will be equal to 4 times 3 times negative 7/10. 3 times negative 7 is negative 21. So we have negative 21/10 plus 1 minus 2. And then to simplify further, on this side, we need a common denominator of 10. And so to get negative 5 in terms of tenths, what you can do is multiply it by a form of 1 of 10 divided by 10. All right, so doing that will give us negative 14/10 minus 50/10. And then on the other side of the equation, we still have 4 times negative 21 divided by 10 plus 1. You can rewrite 1 in terms of tenths. It would just be 10 divided by 10. So we have negative 21 divided by 10 plus 10 divided by 10 minus 2. All right, now simplifying further, we have a common denominator over here, so we can combine the numerators. Negative 14 minus 50 is negative 64, so that's divided by 10, and then that will be equal to 4 times negative 21 plus 10. Right, we can add those numerators because we have a common denominator, and negative 21 plus 10 is negative 11. So we have negative 11 divided by 10, and then we're still subtracting 2. Now, negative 64 divided by 10, that can be reduced. Both 64 and 10 are divisible by 2. 64 divided by 2 is 32, and 10 divided by 2 is 5. So we have negative 32 divided by 5 is equal to negative 44/10 minus 2, right? 4 times negative 11 is negative 44. Now, you can rewrite 2 in terms of tenths. You just need to multiply it by a form of 1, of 10 divided by 10. And so doing that will give you 20 tenths. That's really what we would be subtracting here. 20 tenths. And negative 44 minus 20 would be negative 64, right? So what we get here is negative 32 fifths is equal to negative 64 tenths. But as we've already shown over here, negative 64 tenths does reduce to negative 32 fifths. And so both sides of the equation here are equal. We get negative 32 fifths on both sides, which means that our solution is correct. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to solve this equation and check the solution. The equation is 3 times the quantity 2 minus 4 times the quantity x minus 1, and that's equal to 3 times the quantity 2x plus 8. Okay, so this equation is a lot more complicated than our previous two examples. We have multiple sets of parentheses here, but that doesn't change our strategy. We still want to get rid of those parentheses using the distributive property. And so let's start on this side of the equation. I want to get rid of the parentheses on the inside first, so let's multiply negative 4 by everything in those parentheses. Okay, we're going to multiply negative 4 by x and negative 4 by negative 1. So rewriting the equation, we'll have 3 times 2, and then negative 4 times x will just be negative 4x, because the coefficient of this x is 1, and 1 times negative 4 is negative 4, and then negative 4 times negative 1 is positive 4. All right, and then that will be equal to 3 times this quantity. Let's get rid of those parentheses as well. We can multiply 3 by both of these terms right away. Okay, so we'll take 3 times 2x and 3 times 8. 3 times 2x will be 6x, because 3 times 2 is 6, but you do want to keep that same variable part of x, and then 3 times 8 is 24. So we have 6x plus 24. All right, now we got rid of a lot of parentheses there, but we still have one set of parentheses left. So let's get rid of those by distributing 3 through this quantity. We're going to multiply 3 by all 3 of those terms. We'll take 3 times 2, 3 times negative 4x, and 3 times positive 4. All right, so starting with 3 times 2, that's 6. So we'll have 6, and then 3 times the negative 4x will be negative 12x, because 3 times negative 4 is a negative 12, and then you keep that x, and then 3 times 4 is positive 12. So we have plus 12, and then that's all equal to 6x plus 24. And so now all the parentheses are gone. All that's left to do now is simplify the two sides of the equation and then work on solving for the variable, which is x. All right, and on this side, 6x and 24, those can't be simplified. There's no way to combine those terms in any way. But over here, notice that we have two constant terms of 6 and 12. Those will combine to be 18. So we have negative 12x plus 18 equals 6x plus 24, right? 12 plus 6 is 18, so we can combine those two constant terms. Now we have an equation with a variable term on each side and a constant term on each side, which is an equation we know how to solve. First thing we want to do is combine the variable terms. So let's get rid of this one. Let's remove 6x from this side of the equation. We'll do that by adding the opposite of it to both sides, which would be negative 6x, or you can just think of it as subtracting 6x. So we have minus 6x over there and minus 6x over there. 6x and negative 6x cancel out to be 0, and then negative 12x minus 6x will be negative 18x. All right, you can combine the coefficients and get negative 18x plus 18 is equal to 24. Now, we want to isolate the variable term. You want to get it by itself, which we can do by getting rid of the constant term. So let's add the opposite of that constant, or really what I'm going to do is subtract that constant from both sides. So we'll subtract 18 from both sides of the equation. And so positive 18 and negative 18 cancel out. That's equal to 0. And 24 minus 18 is 6. So here's what we'll get. Continuing our work over here, we're just going to be left with negative 18x is equal to 6. Now finally, the last step to solve for x is to divide both sides by negative 18, the coefficient of the variable. So if we do that here, dividing both sides by negative 18 will give us x is equal to negative 6/18, but that can be reduced. Both 6 and 18 are divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. So we get negative 1/3. Okay, so once again, these negative 18s cancel out. Anything divided by itself is 1. So 1 times x gives you x. And then 6 divided by negative 18 is a fraction that reduces to negative 1/3. And that is the solution that we have found here. But let's check it. Let's plug x equals negative 1/3 back into the original equation and see if we get a true statement. And so doing that will give us this: 3 times 2 minus 4 times x minus 1. So we have negative 1/3 minus 1. And that's equal to 3 times 2 times negative 1/3 plus 8. All right, now simplifying, starting with what's inside the parentheses, we have negative 1/3 minus 1. You could rewrite that 1 to be in terms of thirds. It would be 3 divided by 3. I'm just going to do that right here. You would really have 1/3 minus 3/3. So now we have a common denominator, which means you could combine the numerators. Negative 1 minus 3 is a negative 4. So we have 3 times 2 minus 4 times negative 4/3. And then that would be equal to 3 times 2 times negative 1/3. 2 times negative 1 is negative 2. So we have negative 2/3 plus 8. And then simplifying further, negative 4 times negative 4/3, you can multiply negative 4 by the numerator, which would be positive 16, right? Negative 4 times negative 4 is positive 16. So you get 3 times 2 plus 16/3, which is equal to 3 times negative 2/3 plus 8. Now you could do this a couple ways. You could choose to rewrite 8 in terms of thirds and then add those two fractions. But I think something easier to do here is make use of the distributive property. If you multiply 3 by both of these two constant terms, this 3 will cancel out with this 3. So you'd just be left with negative 2 plus 3 times 8. Okay, you have to multiply 3 by 8 as well. All right, so distributing 3 through this quantity gives us negative 2 plus 24, right? 3 times 8 is 24. And by the way, 3 times negative 2 is negative 6 divided by 3 is negative 2. So however you go about that calculation is fine, but this is what you should get. But then to simplify further, we could do the same thing over here. We can distribute this 3 through this quantity. That will be a little bit easier than rewriting 2 in terms of thirds in order to combine these two values. Let's just multiply 3 through this quantity, and that 3 will cancel out with this 3. Okay, but before we get there, 3 times 2 is 6, so we get 6 plus 3 times 16/3. But those two 3's will cancel out because you're multiplying 3 into the numerator and then dividing it right back out, just leaving you with 16, whatever is in the numerator. All right, so we have 6 plus 16 equals negative 2 plus 24, which is positive 22, right? 24 minus 2 is 22. And then 6 plus 16 is also 22. So you get 22 equals 22, which is a true statement. And so x equals negative 1/3 is the solution to this equation. Let's take a look at one more example for this video. Okay, so here's our last example. One more time, we want to solve the equation and check the solution. This time our equation is negative 1/2 times the quantity 4 minus another quantity of 3b plus 2, and then that's equal to 5 minus 1/2 times a quantity of 3b plus 6. All right, so just like with our other examples, the first thing we need to do here is get rid of the parentheses in this equation. And so what we need to do is use the distributive property. On this side of the equation, I'm going to start by distributing this negative through this quantity. We're going to negate each of these two terms, right? Really what we're doing here is multiplying -1 by 3b and 2, which is just going to change the sign of those two terms. Right now they're both positive, but once we distribute that negative, they'll both be negative terms. All right, so first up we have -1/2 times 4 minus 3b minus 2, and then that will be equal to 5 minus 1/2 times this quantity. Now what I'm going to do is distribute -1/2 through this quantity, so I'm going to multiply -1/2 by each of these two terms. All right, we'll multiply -1/2 by 3b and multiply it by 6. If you multiply -1/2 by 3b, you want to multiply the two constants, and 3 times -1/2, just multiply that 3 into the numerator. 3 times 1 is 3, so you'll get minus 3/2, and then keep that same variable part of b. And then -1/2 times 6, you can multiply 6 into the numerator, and you'll get minus 6/2. Okay, now let's take this one step further. We did get rid of some of the parentheses in this equation, but we still have another set of parentheses we need to get rid of. We need to distribute -1/2 through this quantity. So let's do that. We're going to multiply -1/2 by 4, then we'll multiply it by -3b, and then we'll multiply it by -2. And so if we do that, -1/2 times 4, you'll multiply 4 into the numerator and get -4 divided by 2, but -4 divided by 2 would just be -2. So I'm going to rewrite that as just -2, and then -1/2 times -3b, the negatives will cancel out, we'll get a positive number, and then 3 times 1/2 is 3/2. So we have 3/2 b, because you want to keep that same variable part, and then -1/2 times -2, once again the negatives will cancel out, we'll get a positive number, and 2 multiplied into the numerator gives us 2 divided by 2, which is just 1. So really we have plus 1, and that will be equal to 5 minus 3/2 b, and then -6 divided by 2 is -3. Okay, so now we got rid of all the parentheses in our equation. Now let's simplify as far as we can, and then work on isolating the variable to ultimately solve the equation. And so notice that we have two constant terms on this side of the equation that we can combine. -2 plus 1 is -1, so we have -1 plus 3/2 b. That will be equal to this side of the equation where we have 5 and -3. Those are two constants that can also be combined. 5 minus 3 is 2. So we have 2 minus 3/2 b. Now we have one variable term on each side of the equation and one constant term. So now let's work on combining the variable terms. I'm going to add 3/2 b to both sides. That will get rid of this variable term, right? We're going to add 3/2 b to both sides. So -3/2 b will cancel out with positive 3/2 b, and we'll have -1 plus 3/2 b plus 3/2 b. Those two variable terms have coefficients with common denominators, so we can add the numerators. 3 plus 3 is 6. So we have plus 6/2 b is equal to 2. And so now, let's do our next steps over here. Notice that 6 divided by 2 is 3. So what we have here is -1 plus 3b equals 2. And so now what we need to do is isolate the variable term, which we can do by getting rid of this -1. So if we add the opposite of that to both sides of the equation, which would be +1, if we add 1 to both sides, -1 and +1 will cancel out, and we'll be left with 3b is equal to 2 plus 1, which is 3. So we have 3b equals 3, which we can finally solve for b by dividing both sides by 3, the coefficient of that variable term. So dividing both sides by 3, these 3's will cancel out because 3 divided by 3 is 1. 1 times b is b, so we get b is equal to 3 divided by 3, which once again is 1. So b equals 1 is a solution that we find for this equation. But let's check it. Let's make sure that it is a solution to this equation. Let's plug it back in for each of those b's. So checking our work, we'll have -1/2 times 4 minus 3 times 1 plus 2 is equal to 5 minus 1/2 times 3 times 1 plus 6. Okay, I just replaced each of those b's with 1. Now, simplifying, 3 times 1 is 3 plus 2 is 5. So we get negative 1/2 times 4 minus 5 is equal to 5 minus 1/2 times 3 times 1, which is 3, plus 6, which is 9. And now simplifying further, 4 minus 5 is negative 1. Negative 1 times negative 1/2 will just be positive 1/2. And then that will be equal to 5 minus 9 times 1/2, which would be 9/2, right? You multiply 9 into the numerator, 9 times 1 is 9. Now, we need to simplify this side of the equation further to see if it's equal to 1/2. And what we need to do is get a common denominator. We need to represent 5 in terms of halves. So you can multiply it by a form of 1, of 2 divided by 2. That will give you a denominator of 2. And 2 times 5 is 10. So what we get here is 1/2 is equal to 10 halves minus 9 halves. And now we have common denominators. You can combine the numerators, and 10 minus 9 is 1. So on both sides of the equation, we do get 1/2. 1/2 is equal to 1/2, which is a true statement, which means that b equals 1 is the solution to this equation. Okay, and so with that, we're done. That is it for this example, and this was also the last example for this video, but if you do want to get some more practice with equations involving parentheses, I do have a couple more available on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.